a method that uses pulsed laser light to measure the distance to a target. LIDAR stands for Light Detection and Ranging. It is commonly used to make high-resolution maps with various other applications. Maybe you've seen something spinning on top of self-driving cars. This device is a LIDAR system. Although these sensors might seem silly, LIDARs are one of the most important pieces of hardware for a self-driving car. Depending upon the type of LiDAR system, it may either be in the front of the car or on top of the car. LiDARs act as the eye of the autonomous car, providing a 360-degree view of its surrounding to enable safe driving. LiDARs use ultraviolet, visible, or near-infrared light to image the object. LiDARs can target a wide range of materials, including metallic and non-metallic objects such as clouds, rocks, humans, water, and trees. LiDAR systems on most self-driving autonomous cars can continuously create accurate 3D models up to 250 meters away. LiDAR systems fires off beams of laser light and then measures how long it takes for the light to return back to the sensor. LiDAR systems work well with stationary and non-stationary objects such as pedestrians, cyclists, cars, and trucks. LiDAR systems can also work at night. This is an advantage over cameras which have trouble at night. After measuring the time taken for the light beam to return back to the scanner, the distance is calculated by multiplying the time with the speed and then dividing by 2. Using the angular resolution formula and using the details of the LiDAR system found on the internet, the smallest feature measurable at the maximum range was found to be 1 centimeter. When LiDAR systems is compared with radar and video systems, it is seen that the LiDAR systems outperforms the other two in every single category except in bad weather conditions. In order to overcome this problem in self-driving cars, LiDAR systems are coupled with radar systems. There are two different kinds of LiDAR systems. One's a mechanical LiDAR system and solid-state LiDAR system. Mechanical LiDAR systems are placed on top of the car, while the solid-state LiDAR systems are placed in the front grille of the car. Lasers are part of the mechanical LiDAR system. The wavelength of the laser use depends upon the use of the LiDAR system itself. The maximum power has to be limited to make the laser eye safe and to protect the pedestrians and other drivers. The speed at which an image can be developed is affected by the speed at which it can be scanned into the system. One motor rotates the LiDAR system, while the other motor changes the tilt of the tilting mirror. The LiDAR system rotates at an RPM of 120 to 300, while the tilting rate is between 1200 to 3000 per minute. The photodetector is a device that reads and records the signal being returned to the system. There are two main types of LiDARs based on the photodetectors and receiver technologies, that is the solid-state and the mechanical LiDAR system. The working of a solid-state LiDAR system is seen here. Solid state is compared to the mechanical LiDAR system. It is seen that the solid state LiDAR system is cheaper, more compact, lighter, takes up lower power, has higher performance and higher reliability than the mechanical LiDAR system. The only drawback about the solid state LiDAR system is that since it's in the front of the car, it can only scan 120 degrees in front of the car. Over the next few years, as the technology improves, the LiDAR systems are going to move towards solid state, and away from the mechanical LiDAR